Space exploration. People have studied the skies from before written history. Even without instruments, people were able to figure out much about our world, including that some objects, planets, moved against the backdrop of stars, the timing of equinoxes and solstices, and that Earth was a sphere. Over time, many ancient civilizations used simple instruments to document the motion of objects in the sky. It would be impossible to catalog all the advances made throughout the world, but we will describe a few of them. For instance, Tycho Brahe, in the late 1500s, used this device to accurately locate the positions and apparent motion of the planets and stars. It allowed him to document what he could observe with the naked eye. His data was used by Johannes Kepler to create the model of the solar system with the sun at its center. In 1610, Galileo became one of the first users of a telescope to observe space, including the planets. His observations of the moon and other planets led him to conclude that they were made of similar stuff to that found on Earth. This was a major breakthrough, as previously it was thought that the heavens were made of completely different, ideal materials. He also observed several of Jupiter's larger moons orbiting Jupiter. This led him to believe that our moon orbits Earth and that Earth orbits the sun, lending support to Kepler's theory. From 1917 to 1949, this observatory in Los Angeles County had the largest optical telescopes in the world. Its observations revealed that many of the objects in the night sky were not stars, but were galaxies filled with vast numbers of stars, about 10 to the 11th power stars in each. Edwin Hubble and colleagues published data and analysis that showed that all the stars and galaxies are moving away from us and each other, and that the rate of separation from us increased in proportion to the distance of the object being observed. That data lent support to what became the Big Bang Theory and showed that the universe is much larger than could have been imagined, and that the sun and Earth are a very small part of it. In the 1990s, Alan Guth published his inflationary theory to explain the Big Bang. His theory predicted a pattern of microwave background radiation which would permeate space. In the early 2000s, that theory was tested by the Wilkinson Microwave Anisotropy Probe, a satellite with the capability of determining if that background pattern existed. Its data strongly confirmed the prediction, lending strong support to the inflationary and Big Bang theories. Launched in 1990, the Hubble Space Telescope orbits Earth so as to be beyond our atmosphere. Its images are of galaxies that are 13.4 billion light-years from us, which means that the light being observed has traveled for 13.4 billion years. Its data has, on the one hand, confirmed Hubble's law out to near the beginning of the universe, but, on the other hand, revealed new mysteries about dark energy and dark matter which are still not understood. The Laser Interferometer Gravitational Wave Observatory, or LIGO, is L-shaped, with legs that are 4-kilometer-long vacuum chambers. It can measure motion 10,000 times smaller than the nucleus of an atom. The LIGOs in Louisiana and Washington, shown here, work in tandem. They look for gravity waves and recently discovered 2 black holes merging about 800 million light-years from Earth. In 1969, humans set foot on a celestial object beyond Earth, Earth's moon. Since then, there have been manned and unmanned landings on the moon. Extensive research is being done now to determine if there's water on the moon. This is mostly being done by telescopes looking for the spectrum of water in reflected light from the moon. In late 2020, NASA's Stratospheric Observatory for Infrared Astronomy, or SOFIA, discovered water on the moon. SOFIA flies high enough that the spectrum of water in reflected sunlight from the moon is not interfered with by water in Earth's atmosphere. Accessible water on the moon is critical for humans to live there, and would open up a new avenue for exploration and colonization of space. By the end of 2020, NASA had sent 4 robotic vehicles, rovers, to Mars. These are among the 15 devices that the United States or Russia have landed on that planet. A key element of their mission is to look for water on Mars, also to understand if Mars had water in the past. This would help us understand if Mars could support life now or could have in the past. Mercury is perhaps the least explored inner planet. Its location near the Sun makes it difficult to reach. There have been flybys and satellites put into orbit around Mercury, including the Mariner 10 shown here, which visited in 1973. Here is NASA's Mariner 10, and here's a mosaic image of Mercury composed of 18 pictures taken by Mariner 10. Dozens of spacecraft have flown by or landed on Venus since 1961. The atmospheric pressure is so great that no landing device has functioned on the surface for even an hour. But Venus orbiters have provided a wealth of information about the planet. Venus is in many ways more like Earth than any of the other planets, but it is still not well understood. There have been 9 missions to the outer planets. All studied Jupiter, 4 studied Saturn, and 1 studied Uranus and Neptune. The moons of Jupiter and Saturn have been of great interest. Shown here is the Cassini, which studied Saturn and its moons. Here's Titan, one of Saturn's moons. Voyager 1 and 2 conducted flybys of the outer planets and then continued beyond our solar system. They are the first human-made objects to leave our solar system. They will never return, going outward forever. They launched in 1977 and include information and recordings about Earth, in case they are found by other life forms. Voyager 1 entered interstellar space in 2012, and Voyager 2 followed in 2020. What exactly does it mean to leave the solar system and enter interstellar space? The solar wind creates a bubble in space, the heliosphere, beyond which is interstellar space. The Voyagers are transmitting data from there, data which, traveling at light speed, takes 16 hours to reach us. With advanced measuring devices, it's become possible to study planets orbiting other stars, exoplanets. The first was discovered in 1992, orbiting a pulsar. 3 years later, the first exoplanet orbiting a star was found. Since there are about 10 to the 22nd power of stars in the universe, it's expected that many of them will have planets, and some of those planets could be like Earth. To know how many planets might be in the universe, a survey of the planets orbiting nearby stars was launched. A key part of that effort includes the Kepler Space Telescope. The Kepler mission is to survey stars near us to determine how many planets are orbiting them and what those planets are like, including how many are like Earth and might harbor life. Kepler uses the transit method to discover planets. As a planet crosses in front of a star, the light from the star dims. By studying the change in the star's light over time, the planet's size, orbital period, and orbital radius can be determined. As of November 2020, 4,306 planets have been discovered. Of those, 163 Earth-like planets have been found. The closest star to Earth, Proxima Centauri, has been found to have a planet much like Earth, in the habitable zone where liquid water should be found. Will we find life there?